Hi, welcome to Lesson 5 in our geometry series. This is Pythagorean Theorem, Part 2. In our last lesson, we learned how to find missing side lengths of right triangles using the Pythagorean Theorem. Today, we're going to cover a few topics, the first of which is Pythagorean triples. So a Pythagorean triple is something that you begin to recognize as a repeating pattern in these right triangles. And what it is three numbers that always work out evenly on a right triangle. So we have Pythagorean theorem, c squared equals a squared plus b squared. And one of our triples is a 3, 4, 5. It's very common. You will begin to recognize it. So if we had a right triangle, back up a minute. Sides 3, 4, and 5, let's verify that on our calculator. Let's see if 3 squared plus 4 squared is literally 5 squared. So we do 3, up arrow 2, directional pad to the right to get off of the superscript line, plus 4, up arrow 2, directional pad to the right to get off of that exponent line, enter. And yes, 3 squared plus 4 squared is 25. So that does work out. 25 does equal 25, and we know that 5 squared is 25. So what that means is if you have a triangle that is a right triangle, and the side lengths are 3 and 4, what do you already know the hypotenuse has to be? A 5. What if you have the 3 and the 5? The hypotenuse is 5, a leg is 3, then you already know the missing leg must be 4 because 3, 4, and 5 is a Pythagorean triple. So as you begin to recognize this pattern, you can save your time in these computations and just know, oh wait, 3, 4, 5. I don't need to do that on my calculator. And there's another one, 6, 8, 10. So 10 squared equals 6 squared plus 8 squared. Let's verify that on our calculator. So we have 6, up arrow 2, directional pad to the right, plus 8, up arrow 2, directional pad to the right, enter. That is 100. Well, hopefully you remember 10 squared, 10, up arrow 2, directional pad to the right, enter. And that is 100. So yes, 100 on both sides. So 6, 8, 10 is another Pythagorean triple. So if you have the hypotenuse 10 and a leg 8, then you automatically know the short leg must be 6. And you'll see a lot of these. The most common is that 3, 4, 5. There are others. You probably won't get to where you recognize those, but you definitely will get to the point where you recognize a 3, 4, 5 triangle. And you can say without a doubt that is a right triangle because the sides are 3, 4, and 5. So you can work this backward. You can also say without a doubt, if you have two legs, 3 and 4, and you know you have a right triangle, hypotenuse is 5. But sometimes you might be given something like this. Is that a right triangle? Yes or no? And you're not given a measurement. You can, without a doubt, say, absolutely, that is a right triangle because the side measurement, the two legs and the hypotenuse are 3, 4, and 5. So I can say without a doubt, because of Pythagorean's theorem, that yes, indeed, this is a right triangle. So it works both ways. Now there's another thing that we can do with Pythagorean's theorem, and that is we can identify different types of triangles, not necessarily a right triangle. So let's do just a little bit of review from our angles. A right angle is how much? 90 degrees. And if a triangle contains a right angle, then that's a conditional statement. If a triangle contains a right angle, then it is a right triangle. There is a conditional statement way back from lesson 1. Told you we'd be using these. And if we had to underline the hypothesis, a triangle contains a right angle. That's our hypothesis. And if we underline the conclusion, it is a right triangle. And you could figure out your contrapositive, inverse, and converse from that. And this particular conditional statement is true. Yes, yes, indeed, it is. Okay. Now, there's another not right triangles, but remember your obtuse and acute angles. So an obtuse angle is greater than 90 degrees. And if a triangle contains an obtuse angle, then it is an obtuse triangle. Also a true conditional statement. And we have the last of which, remember your acute angles, it's a cute little angle. That's how you can remember which one of these is less than 90 degrees and which one is greater, because a cute little angle. If a triangle contains all acute angles, then it is an acute triangle. But we might not always have a protractor with us. And we might be on a test and only have side length of a triangle, and we have to figure out, is it obtuse, right, or acute? So we can use the converse of the Pythagorean theorem to figure this out. The converse of the Pythagorean theorem is what we're going to use. So if we imagine in this acute, obtuse, and right triangle that we're going to apply the properties of the Pythagorean theorem, where the longest side is C. Now, it can't be the hypotenuse if you're not a right triangle, but we're going to apply that concept of C squared, which is our longest side. Only in a right triangle is it the hypotenuse. And in a right triangle, it equals A squared plus B squared. But there's another relationship between your longest side and your short legs in the obtuse and acute triangles as well. So if you have an obtuse triangle, your longest side, which we will call C, it's not the hypotenuse because we're not talking about a right triangle here, but we're going to use that same concept of the hypotenuse being the longest side in this relationship. And in an obtuse triangle, your longest side squared is greater than your two legs, the sum of which squared. The sum of your squares of your two legs. Woo! A squared plus B squared. So if you put in your longest side squared, and it's bigger than A squared plus B squared, where A and B are your legs, or your shorter side, then you know beyond a shadow of a doubt that you have an obtuse triangle. So for an acute angle, that one is where all of the angles are less than 90 degrees. They're all cute little angles. And in this one, it is just the opposite. So your square of your longest side will be less than the sum of the squares of the length of the leg. And what this is referred to is, this law is the converse of the Pythagorean theorem. So let's put it to use. Let's see what you're going to be doing with this on your homework. So if we just go and look at number 16. Numbers 1 through 15 have pictures for you. Actually, we're going to do 15 and 16. Let's do one of each example. So in question number 15, you have a right triangle. Wait a minute, you don't have a right triangle. We don't know what we've got. We're not doing 15. We're going to do 14. 15 is the triple, and you will know that when you look at it. We're going to do 14. You're given some measurements here. You're given 3, 3, and 5. Now, although the picture looks like a right triangle on every one of these, you cannot go by a picture and the way it looks. If you do not have this marking on your picture, you do not know that this is the right triangle if you don't have that. So all of these pictures on this worksheet, while they appear to be right triangles, that doesn't mean anything at all in geometry. Without appropriate markings, you cannot go by a diagram because they're never drawn to scale. All right, so what we need to do is classify this triangle. So we're going to use the Pythagorean theorem and its converse to try to figure this out. So I know we have 5 squared as the longest side square. I don't know what goes in the middle. I don't know if it's equal, greater than, or less than. And on the right side is the square of the two legs. And we're going to add it up. And what I'm trying to figure out is what goes in the middle. Is it, excuse me, equal, greater, or less than? What goes there? Because if it's greater, we have an obtuse. If it's less, we have an acute. And if they're equal on both sides of that question mark, then we have a right. So 5 squared, let's go look at our calculator. 5, you can push the x squared button, enter, 25. Well, 3 squared, 3, push the x squared button, enter is 9. So 5 squared is 25, 3 squared is 9. So we know we have 25, and we have 9 plus 9. So that gives us 25 and 18. Well, what goes there? Definitely the greater than. So 25, the square of the longest side is greater than the sum of the squares of the legs. that means you have an obtuse triangle. Anytime that is bigger, you have an obtuse. Okay? 17 does not give you a diagram. Instead, 17 gives you a list of sides. It says 6, 6, and 10. Well, the longest side is 10. So 10 squared. We don't know what goes in the middle. 6 squared plus 6 squared. So 10 squared is 10 times 10, which is 100. 6 times 6 is 36. So we have 172. Well, that is also greater. So that would be obtuse. And that is how you do that. This is 1 through 30. Remember, as always, your first step is you're going to upload a picture of your handwritten notes from this video. You're going to show all work on a piece of paper from your worksheet. You don't need to print it. Do not print it and circle answers. That is not showing work. Write the problems down, draw the pictures on a piece of paper, and show all of the work that you do step by step, just like I did in this video. You're going to upload a picture of that. And 3, you're going to submit the answers, your multiple choice answers, onto the form for your grade. All right, have a great day. I'll see you in the next lesson.